Hello friends, today we are going to learn about what is the conjugate beam and the differentiation between the actual or the real beam with the conjugate beam, as well as the justification of the support condition which is changed from the real beam to the conjugate beam. So first of all, if we take the definition of conjugate beam, which is it is simply defined as an imaginary beam, or we can say that the arbitrary beam having the length equal to the length of actual beam. So real beam and conjugate beam have the same length of the span. Now the next point is loading as M over EI diagram of loaded beam. It means the moment diagram which is divided by the flexural rigidity as a EI, and that moment diagram which is converted into the loading in the conjugate beam, but the changes in the support condition according to the rule of conjugate beam. So there may be a changes in the support condition for the conjugate beam, but the length is constant for both the beam as in the actual beam or in the conjugate beam. Now why conjugate beam is going to be used? So according to the conjugate beam, according to the conjugate beam method, slope, or we can say that the rotation in the actual beam at any point, which is given by the shear force value of conjugate beam at the same point or corresponding point. So it simply says that if we have to find anywhere this value of slope, then we have to convert that beam into conjugate beam, and if we calculate the shear force at same location, it will give the value of slope at the corresponding point. And the second point is a deflection in the real beam at any point, which is given by the bending moment in the conjugate beam at the same point. So if we have to calculate the deflection at any point of the beam, then we have to find out the bending moment in corresponding conjugate beam. Now conjugate beam is used because of the Macaulay's method having the lengthy method for the calculation of slope and deflection. So for the modification of the method, conjugate beam is going to be used. Now we have to differentiate between real and conjugate beam by the support condition. Now in real beam, if we have a hinge support or roller support, then for the conjugate beam, the support is not converted into the another support. It means hinge support becomes hinge while roller support becomes roller support. But if we have the fixed beam at any location at a real beam, which must be converted into the free end. It means if we have given a cantilever beam having the support A as a fixed, so that in the conjugate beam the support A is a free end, while the free end at any actual beam must be converted into the fixed support. So in simplest view, if we have given a cantilever beam, then if we take the mirror image of cantilever beam, so it is converted into the conjugate beam. And the another point is any internal support of the real beam must be converted into internal hinge. So this is the changes in the support condition according to the real beam to the conjugate beam. So we are going to use these different support condition. M over EI diagram of the loaded beam, which is as a loading in the conjugate beam, and the length is the same as a actual beam according to the conjugate beam definition. Now before going for the example, we have to take some fundamental. If we have these two types of curve in the diagram, then the total area, or we can say the total loading of this curve is 2/3 into B into H, where B is the base length of the loading while H is the value of loading. And for this type of curve, we have total loading as 1/3 into B into H, where H is the rate of loading while B is the base of the given curve. Now for the moment, we have to take the CG distance. So for this type of curve, our CG distance is at 5/8 of base width, and from the height, or we can say that the rate of loading, it is at 3/8 of total base length. And for these types of curve, it is at 3/4 of base width, and from the rate of loading, it is at 1/4 of base width. So this is going to be used for the calculation of conjugate beam which is loaded through the UDL, as we know that the UDL bending moment is of parabolic curve. Thank you.